Hello everyone, welcome to today's video. In this video, we're going to talk about a design pattern, chain of responsibility, and we're going to see how we can implement it in Swift. So I prepared an example for this, and we're going to be working on a small set of code here. So what I have here is product handler. By the way, I'm going to talk about what this design pattern is shortly, but first I want to show you the existing code, and I'm going to transition to what it does by talking about the problem it solves. So we have product handler over here. It's a simple class. It has access to three different services, like regular product service, expired service, and premium product service, and then handles a product. So if you jump to product is just a simple struct with a name, quantity, price, and product type. And the product type is the important differentiator here, which is an enum that has three different cases: regular, expired, and premium. So, and also in product handler, as I mentioned, there are some services, but there's just a small services to, as an example, they don't do anything, right? I just show them there to kind of indicate this handler has kind of too many responsibility by having access to the three different services. Okay, so what does this product handler do? It has a handle product method, and it switches on the product, and then depending on the product type, it calls a different method, like handle regular product, expired product, or premium product, and then talks to the corresponding service. I also have some comments here, as you can see, like we can be potentially doing more logic here. This can kind of get crowded with the additional logic for different product type. Okay, so like what is the chain of responsibility and how it can help? So as you can see, this handler is pretty simple for now, but imagine if we have like 25 or even 50 different cases of a product. Like what if you would have to worry about different product types? Right here, we would have a gigantic switch and potentially introduce more services to handle all these different cases and have a lot more logic, just all of them implemented in a product handler. So product handler will get really difficult to handle or maintain over time. It will be hard to reason about it or refactor it, make changes on it, and also write unit tests to it, because we would have too many unit tests in just one file. Okay, so what is the chain of responsibility that can help? So chain of responsibility helps that we will have kind of a chain, and we're going to run through the chain until we handle a product. So it will help us to divide this product handler's responsibility to sub chain processors, and we are as nodes of a chain, we are going to have different nodes for each product type to handle specifically that product type if needed. Normally, the chain is set up kind of like linked list. So you initialize the first node, then you set the next node to the first node, and you set the third node to the next second node, and so on. But it's a bit cumbersome to set up. That's why I like to do this as an array, right? Like I will add all the nodes in an array in order, and we're gonna run through like a for loop in an array to make sure we are handling our products. You'll understand it better as you are coding as well. Okay, so we have it here, the product handler. Now how we can implement this chain. So I'm going to create a protocol here, like to process the products. So I'm going to call it product processing. And it's going to have one method like process product that will take a product. That's it. And now, because that's what we're going to call from the handler. And now create our chain. We're going to come here and say struct product processor chain. You don't have to name it chain, but since the design pattern is called chain of responsibility, I want to make it explicit here. Okay, we conform to this protocol, we implement this process product, and we're going to implement this body later on. So now this will be our main chain, but we're going to need sub chains, like chain nodes for each product type. So let's do that. But we also going to need we're going to need a protocol for each chain node to conform to. So first, let's write that protocol. Protocol product processing node. That's going to have a similar product, a similar method here, but it's going to return a boolean to indicate if this node handled this product. Now let's write our first node. Let's go back to our product handler. As you can see in the switch case, we are handling different products: regular, expired, and premium for each case of product type. So what we're going to do is we're going to create a processor for each one of them. So now let's begin with the regular. We're going to come down here, and I'm going to say struct regular product processor. That conforms to product processing node. And now we're going to implement the process product method. And let's get the service this processor needs from the product handler as well. As you know, in order to handle the regular product, you need to have access to regular product service. So I'm going to grab it over here. I'm going to come down here, paste it, get an initializer for it, and we can also give it the default service that it needs. Okay, so now we have our processor set up, and now we're going to see if we're going to handle it. So the idea is we're going to check only if the given product is what we're interested in. Otherwise, we're going to return false to indicate that we want to pass it on to the next processor. So what we're going to do here is that we're going to say guard case dot regular is equal to product, the product type. Otherwise, we're going to return false. But if that's the case, that we get a regular product, we can directly interact with that product by calling our regular product service and passing our product. And we can also do any additional logic if needed, right? Because it's just for regular product processing. And then eventually, we're going to return true. As you can see, this is a synchronous code, but that's fine. If you need to schedule something to be executed in parallel, you can easily schedule a task, initialize a task to handle different things, as long as you return true synchronously in the end. There's no problem with that. Cool. So now we have our regular product processor, and now we're going to create one for expired product and one for premium product as well. It's going to be very similar, but only focusing on the item type we are responsible. So the real magic here is that we are checking this guard case regular for the given product's type. And then we're going to see if we can work on that. Okay, let's come here and say struct expired product processor. It's going to be very similar to one above. So I'm going to be a bit speeding up over here. I'm going to come here and say process product. And over here, we also need the service for expired product processor. I'm going to grab it from our product handler as well. Come down here, initialize with the expired product service. Dependency injection is something I usually use, and I also recommend using, even though maybe you don't need it, but it helps with unit testing later on. But it's to make it easy to set it up. You will see later on our main processor. It's also good to give default values here. Okay, now we're going to see if this is what we care about, the product. We are expired product, so we need to check if it's expired. If not, we're going to return false. Again, then if it's expired, then we can process it and call the update product method in the service, and then eventually return true. And I'm going to do the same quickly for premium product processor, and also conform the product processing node. Grab the service needed right here and initialize it. Also default value of the service. Okay, now also implement the process product methods. Similarly, we're going to care if it's a premium product, product type. Otherwise, we're going to return false. And if it's premium, we're going to update it, handle it here by talking to our service, and eventually return true. So now we have our node processors in the chain, and now we're going to come back here to our main product processor chain, and we need to now set it up, right? We need to set up our chain, and the way we do it is with an array. As I said earlier, we can come here and say private let subprocessor chain. That's a type of array of product processing node. and we can initialize it with all the processors. So regular product processor, expired product processor, and premium product processor. So what's gonna happen is that we're gonna run through this chain until we can handle a product. So I'm gonna come back here now and say for processor, before I do the for loop though, first let's create a boolean here, variable did process product, and set it to false. And now we can come here and say for processor in subprocessor chain, guard did process product is equal to false. Otherwise, break from the loop. If it's false, try to process it with the current processor. So what we're going to do is we're going to call processor that process product, which is a given product. And it's going to return a boolean to us, and we're going to set it to did process product here. And now in the next run loop, after this ends, we're going to check if it's false, we continue. If it's true, that means we handle the product and we can break from the processor. But I want to add an additional check here. I want to assert that at the end of this for loop, the did process product is true. Because we won't have a compiler support, you will see, because we are not going to be switching anymore. And when we introduce a new item type, we are not necessarily get a warning to implement a new subprocessor for this new item type. But if we have the assert here and we forget about it and run our code, we're going to get an assertion here because for this new product type, we did not handle it. Actually, we can also get some sort of a compiler support for this if we would make our product type case iterable, and in unit tests we write unit tests for each case, like we run like a for loop for each case for the product type, then we would get a warning, because not a warning but a test failure, because our test wouldn't pass, right? But that's like that will be too long to implement here now. That's why I'm not gonna do it here, but something so you keep in mind, like with case iterable and unit testing, you can have a better mechanism against forgetting, handling new product types. Okay, so that's it actually for this chain. Now it's going to be processing it one by one until it's handled. Now we are going to use this product processor chain. So we can come back to our product handler, and now we're going to inject the private let product processor chain, type of product processor, product processing. And then I'm going to inject it as well, and we can give it the product processor chain as a default value, and come down here and then initialize, set it to ourself product processor chain. So now we can use this chain to handle our product, so we don't go into the switch anymore. I'm going to remove this, and I'm going to come here and say product processor chain process product given product, and that's it. The rest will be handled by the chain itself. So now my product handler can get rid of all this logic and also all these services, and can be kind of like a lean layer that is, publicly available for updating products as needed in the code. Yeah, so as you see, like we are kind of done right now. We created our chain with our chain nodes, and yeah, we run through the for loop to make sure we are handling a product with our chain. But you might be thinking, is it really worth it? Because it's just like we had just 3 cases. It was not that crowded, which is true. Like I'm not recommending that you use this for every switch case you have in your app, because like it can be an overkill, definitely, because you're creating entities. It also has a cost, right? Like you have different files to worry about, different protocols to worry about, different test files you are going to write if you're writing unit tests. But imagine a scenario where you have 25 or even 50 cases, right? But in that scenario, this becomes really useful, because if you have 50 cases of an enum that you need to switch on, first of all, you would have a gigantic switch. And then you might have added different services to the product handler to make sure you're handling all the product types properly. And you'll have so many different logic functions in this product handler to make sure you can handle everything. And that would also, put a lot of responsibility on product handler, which is not nice, makes it really hard to maintain, and would also make it hard to maintain its test file as well. Like you would have a unit test code with so many different tests, and it would also be hard to maintain and iterate on. So yeah, like if it's too many cases, it's definitely useful, and I recommend you consider using this. And I can give an example like when this can be helpful. Imagine a scenario where you need to process deep links, right? Like you might have so many deep links in your app that you need to handle. Then this can come really handy because you're probably going to need to handle each deep link differently. And then this can be really helpful to separate those responsibilities into their own entities, like sub-chain nodes with this chain of responsibility approach. And it can also be, notification handling, like you have so many different notifications that you want to handle. Then you can also use this approach to make it easy to maintain. So yeah, that's it. That's how I implement the chain of responsibility in Swift. As I said, the array approach is not always used. The regular setup is to set the chain like a linked list, connecting them one to another until it's handled. But I think this also works well. It's easier to set up. It's just an array, and then each product processor handles only for the product they are interested in, and otherwise they are passing on to next with returning false. Okay, yeah, that's it for today's video. Let me know what you think. Do you think this can be helpful in some scenarios? Do you think it can help you architect or design your code better in some scenarios? And yeah, let me know what you think about it. And I hope you like this video and you find it useful. So yeah, I will see you next time.